All right, so definition 3 is an extremely important and useful definition. We'll be talking about critical points a lot throughout this section and continuing onward through the next few sections. So a critical point is a way for us to hone in on and try to find where a function has a local min or max. So a number c in the domain of f is called a critical point of f if either one of two things happen. Either the derivative is equal to 0 there, or the derivative does not exist. So the reason why these two criteria are important and useful for helping us try to locate local extrema, is because of the following features. Above, in this graph that we looked at in the previous video, notice that for this function, f is differentiable everywhere, okay? So I made this differentiable. But for all of the local mins and maxes that exist here, notice that the tangent line at them all is horizontal. So we know that a local min or max, if it does occur, and our function's differentiable, then we know that the tangent line at that location has to be horizontal. So if your function is differentiable and it has a local extrema, we know the tangent line has to be horizontal. Example 2 that we talked about says something slightly different, although it's subtle. It asks, at an extrema, must there be a horizontal tangent? Notice here that there is no additional assumption of the function being differentiable. A function can have a local min or max and not be differentiable. That just means it has to be the smallest or largest value. So here, this is a local minimum because in the little area, the little local area near this point, it is the smallest value compared to any of these other points. But at this location, the derivative doesn't exist. So this is precisely why we're looking for these two things, because they're going to help us try to locate where we have local extrema. Because based on what we've observed so far, local extrema only occur at locations where the derivative equals 0 or does not exist. Now again, this doesn't mean that just because a function's derivative is 0, or that a function's derivative doesn't exist at a certain point, that doesn't mean that there necessarily is a local extrema at that location. It just means it's a candidate.